We'll be dividing a polynomial by a monomial. Then we'll be doing some long division where we're dividing by a binomial or even a trinomial. And then we're going to learn this new idea called synthetic division. So here we go. So the first thing we'll do is we'll write the division problem as a fraction and then split up into fractions using the common denominator, and then we'll just simplify each part. So we're going to take, in fact, to save a little time here, instead of having the division sign there, we're going to go ahead and dividing by 3xyz, we can write it like this. And so that's really what we're looking at. We're dividing by that, so we can just write it as a fraction. And now this is the common denominator of these three parts, or oftentimes we think of common denominators. We have 2/7 plus 3/7, and we think, well, that's a common denominator, so we can write 2 plus 3 over 7, or 5/7. It's also true that we can start with something with a common denominator and split it up into two fractions, and that's what we're going to be doing here. So we're going to put this 3xyz under each of our terms. Now what we'll be doing is looking at each of these terms separately and simplifying them. So here, looking at the coefficients, 3 goes into 3 once and 3 goes into 3 once, so that simplifies x squared over x. This is x times x over x, so one of these x's, so we'll have just x to the first reduces with this one. Maybe we can use a different color here, and then y cubed over y. This y will cancel with one of these y's, and we'll have y squared, and then we'll still have a z in the denominator. So let's go ahead and write that term. We're left with y squared in the numerator, and in the denominator we just have a z. So y squared over z. Coming to this next term, 3 goes into 3 once and 3 goes into 9 3 times. X to the 5th over x. This cancels with one of these to become a 4. We also can think 5 minus an exponent of 1 is 4. Y simplifies with y, and z squared simplifies with z, and so we're just left with a single z in the numerator. So this is 3 x to the 4th z just over 1, everything's simplified here, and then minus, and we're going to come simplify this last one. Nothing reduces with the 3. X to the 4th over x. This will be cubed now. This will simplify with the x. The y's simplify, and z to the 5th reduces with z to have 4 z's up here. And so this last fraction will be x cubed times z to the 4th over 3. And that's how you do those when you divide by a monomial. Put that under what you're dividing into and then split it up into parts and simplify. Polynomial divided by a binomial. In fact, for this first part using long division, it doesn't necessarily have to be a binomial. It could even be a trinomial. And if you remember long division, we would divide and then multiply, then subtract, and then bring down. And that's the process we're going to follow here. So let's set up this division problem. This is going to be x plus 3 divided into 2x squared plus 4x minus 9. And we start with our first step of dividing. And there's two ways to look at this. I'll show you both as we work through this question. Really, when we're doing the dividing part, we only look at the first term here of our binomial, and we'll work our way through here. So we think, what's 2x squared divided by x? So we think division, and the x would reduce with an x, and that would be 2x. So when we divide, we just would put 2x here. Another way, and I'll just talk through this now, another way to think about this is x times what gives me 2x squared. X times what, and that's what goes here, gives me 2x squared. And we obviously need a 2, and we have an x. We need another x to get us to x squared. We now multiply So 2x times x is 2x squared. So we have 2x squared. And then we do multiply by the 3. 2x times the positive 3 is 6x. So there's our multiplying step. And next we subtract. Now when we subtract, we often think adding the opposite. So we're going to go ahead and change the signs and then just add these. And so we get 2x squared minus 2x squared, which we should get a 0. That one should always cancel. 4x plus negative 6x is negative 2x. So we just subtracted and now we bring down. So we'll bring down this negative 9. So we're back to dividing. And so we're going to think negative 2x divided by x. So we can write it as a division, negative 2x divided by x. The x's would reduce and you would get negative 2. Or we could think what times x gives me negative 2x, and that would be negative 2. So either way we think of that, we get the negative 2. Now we're back to multiplying. So negative 2 times x is negative 2x, and negative 2 times 3 is negative 6. And we're going to go ahead and subtract. Remember, subtracting is like adding the opposite, so we'll change these to the opposites, and then that becomes 0, and again that should become 0, and then we get negative 3. And now we come here and try to divide negative 3 by x, and it doesn't work. We can't simplify that at all, so we know that we're finished. We can write this one of two ways. We can either write remainder negative 3, so that would be an answer, or the other option, we could also put plus negative 3 over what we were dividing by x plus 3. So either remainder negative 3 or this fraction here. We'll be switching back and forth between those different options. And so here's our answer with written as a remainder. Let's do one more as a practice. So here we're going to take x plus 2, and we're going to divide it into this x to the 4th polynomial. Now what we should do here is we're going to plan ahead, and we have an x to the 4th, and then our next term is x squared. We're actually going to leave a space for what's missing, like there's no x cubed here. Well, how do we write there's no x cubed? We could write, well, there's a 0x cubed, and actually there's a not a linear term either, so we could put a 0x. And so having that space there is helpful, so our like terms will be lined up. So we can either leave a space or write the zeros in there. I'm going to go ahead and write the zeros in there. There's 0x cubed, which seems unnecessary to write that, but you'll see as we move forward that it's nice to have there for like terms. We also have no x's, so we can put plus 0x, and then we have minus 12. And we'll extend the division sign here, and we'll go ahead and work through this. We can start by dividing, and so we can think x to the 4th divided by x, or again we could think what times x gives us x to the 4th. Either one of those will give us x cubed. And now we'll multiply. We multiply here, x cubed times x is x to the 4th. X cubed times 2 is 2x cubed. So we multiplied, and now we subtract. So when subtracting, we like to change our signs, so we'll change the signs. They were both positive, now we'll change them to negative, and we'll go ahead and combine those. This should be 0, and this is why we write the 0x cubed, because now we have like terms lined up, and we can just say this is negative 2x cubed. We'll go ahead and bring down the 3x squared, so positive 3x squared, and we're back to division. So x into negative 2x cubed, well, that would be negative 2x squared. Multiplying gives us negative 2x cubed, and then negative 2x squared times 2 is minus 4x squared. And again, we're going to subtract. When we subtract, we can change our signs. So this is change this negative to a positive and this negative to a positive. And we combine those, we get 0 again, and 7x squared. And then we bring down the 0x, and that will actually help us line up our terms again. So x into 7x squared, we could divide, or we could think what times x gives me 7x squared, and that would be plus 7x. Multiplying, we get 7x squared plus 14x. Gotta subtract again, so we'll change these signs. And that gives us 0 and negative 14x. And then we have our last thing here to bring down, negative 12. We divide again. X times what gives me negative 14x, and it's negative 14. Multiplying, we get negative 14x. Then negative 14 times 2 is negative 28. We subtract once more by changing the signs. And this is 0, and this is 16. And x does not go into 16, so I'm going to go ahead and write as a fraction this time. So plus 16 over what we were dividing by, which was x plus 2. So that is a review of long division, which we can use for polynomials.